Okay, so when we're using the quadratic formula, you want to put it down right away. It's probably not a bad idea. Negative b plus or minus the square root of b squared minus 4ac over 2a. And that fraction bar goes under everything in the numerator, not just the radical. If my trinomial is already equal to 0, I can set my a, my b with their signs right away. So now it's negative 8 plus or minus 8 squared minus 4 times 1 times 14 all over 2 times 1. Negative 8 plus or minus 64 minus 56 is going to be 8 over 2 times 1, which is 2. Negative 8 plus or minus, if I can simplify that 8, I must do so. In this case, I can. It becomes 2 root 2 over 2, and the answer needs to be split up. Negative 8 over 2 is 4, plus or minus 2 over 2 is 1, so it's literally just root 2. And that is your answer. Second one, my a is 2, my b is negative 6, my c is negative 9. It's important to keep the signs together. Negative, negative 6 plus or minus. Negative 6 squared minus 4 times 2 times a negative 9. And that all goes over 2 times 2. Negative, negative 6 is 6. Negative 6 squared is 36. 4 times 2 times 9 is 72. The double negatives make it positive. So 36 and 72 is 108 over 4. The 108 can be simplified. 2 and 54, 2 and 27, 3 and 9, 3 and 3. Pair of 3s, pair of 2s, with a 3 left over. So that becomes 6 plus or minus 6 root 3 over 4. And that needs to be split up. 6 over 4, 3 halves. 6 over 4, 3 halves, times a root 3. And that right there. Now the next two, my advice is this. You can go right to the quadratic formula if you want. If you can reduce or take a GCF out, that would be my advice. Because it will make your numbers much smaller and much easier to work with. Now instead of A being 3, B being 15, and C being 6, my A is 1, my B is 5, and my C is 2. So negative 5 plus or minus 5 squared minus 4 times 1 times 2 over 2 times 1. I would argue that's a much more manageable problem. Negative 5 plus or minus 25 minus 8 is 17 over 2. And this would be the answer. Negative 5 halves plus or minus root 17 over 2. Now, some teachers may have you just leave it as negative 5 plus or minus root 17 over 2. I'm a fan of splitting it up. Second one, same deal. I'm going to divide everything by 2 if I can take out a GCF. X squared minus 4x plus 9 equals 0. My A is 1, my B is negative 4, my C is 9. Negative, negative 4 plus or minus. Negative 4 squared minus 4 times 1 times 9 over 2 times 1. Negative, negative 4 is 4. 16 minus 36, negative 4 squared to positive 16, minus 36 is negative 20 over 2. Negative 20 simplifies to 2i root 5 over 2. and it's 2 plus or minus I root 5 is my answer. Now, before doing quadratic formula, we've got to get it all equal to 0. So I can't start my quadratic formula until I'm equal to 0. Then if I can get a GCF out, I'm going to do it. This will keep your numbers much lower. Now, you could have used 8, 4, and negative 28, but now you're going to be breaking down a much bigger radical. I'd rather break down the radical of this, where my A is 2, my B is 1, and my C is negative 7. That's going to be much easier to work with. Negative 1 plus or minus 1 squared minus 4 times 2 times a negative 7. All over 2 times 2. Negative 1 plus or minus 1 plus 56. The double negative here becomes positive. 4 times 2 times 7 is 56. 1 and 56 is 57. And if you can't break down the radical, which you can, it actually makes for a simpler problem. That's literally the answer. If you didn't take the GCF out, you should get to the same answer, but you're going to have a 16 on the bottom, a 4 here, and the radical is going to be much higher. Here, we always want to keep the A positive. So I do adding 8x to both sides and adding 20 to both sides. My A is 1, my B is 8, my C is 20. Negative 8 plus or minus 8 squared minus 4 times 1 times 20 over 2 times 1. Negative 8 plus or minus 64 minus 80 is negative 16. Square root of negative 16 is an easy one. Square root of 16 is 4. So the square root of negative 16 is 4i. Negative 8 over 2 is negative 4. 4 over I over 2 is 2i. And there's our answer, negative 4 plus or minus 2i. We're simply using the b squared minus 4ac. If it's greater than 0 and a perfect square, 2 rational solutions. Greater than 0 and not a perfect square, 2 real solutions. Equal to 0 is 1 double root. Less than 0 is 2 complex solutions. If you can take a GCF out, do so. 3x squared plus 12x plus 7. 12 squared minus 4 times 3 times 7. That's 144 minus 84. 60 is greater than 0. It's not a perfect square. So 2 real solutions. Here, there's nothing to take out GCF-wise. 6 squared minus 4 times 1 times 10. 36 minus 40 is negative 4. It doesn't matter if the number's negative, whether it's perfect square or not. If it's positive, that matters. But if it's less than 0, it doesn't matter whether it's perfect square or not. You're still getting 2 complex solutions. Negative 7 squared minus 4 times 6 times a negative 18. 49 plus 432. That adds up to 41. That's another positive number. That's obviously greater than 0. 41 is not a perfect square. So we do 2 real solutions. Negative 24 squared minus 4 times 9 times 16. Negative 24 squared is 576. 4 times 9 is 36, times 16 is also 576. 0 equals 0. When the discriminant equals 0, it is one double root. Essentially, this comes down to knowing the rules. Before I can do anything with the discriminant, I've got to get everything equal to 0. And then, once again, if you can get a GCF out of there, do it. It's going to make your numbers easier to work with. 2 squared minus 4 times 1 times 4. That's 4 minus 16. Negative 12 is less than 0. It's 2 complex solutions. I'm going to add 7x and subtract 9 on both sides. 2x squared plus 7x minus 9 equals 0. You can't go to the discriminant until it's equal to 0. 7 squared minus 4 times 2 times a negative 9. 49 plus 72. And 49 plus 72 is 121. That is greater than 0. It's also a perfect square. So your answer is going to be 2 rational solutions. So remember, when that number is greater than 0, that's when we have to check if it's a perfect square or not. Okay. All right, I will stop.